Welcome to part 3 of your Unit 1.8 Acids, Bases and Salts topic. We're going to be starting on page 13 this time, looking at the reaction of acids with metal. So if you turn to page 13 in your booklet, it outlines the reaction of acids with metals, and that's our first of 4 specific reactions of acids that we need to look at, reactions of acids with metals. And the first thing you need to learn is your general equation for what happens when a metal reacts with acid. So when a metal reacts with an acid, we get, as we discussed earlier, we always get a salt. And how we name that salt depends on the metal and the acid used, as we've already practiced in part 2. And then the side product is hydrogen. Okay, you need to be familiar with that general equation so that you know that when a metal reacts with an acid, we always get hydrogen given off. And that will give us a clue as to some of our observations. So you can see here you've got an example of reacting sodium with sulfuric acid. And you can see that the name of our salt is sodium, coming from the sodium metal. And then the second part of the name of the salt is sulfate, coming from the sulfuric acid. Down below, you have an observations table. And the first reaction we're going to look at, which you'll need to fill in, is we're going to look at the reaction of magnesium with sulfuric acid. Okay, so you can already be thinking about what your products are going to be for this reaction. Remember, going up to your general equation again, you're always going to get, with these types of reaction, you're always going to get a salt and you're going to get hydrogen. So what's the name of our salt going to be? Well, the first part of the name comes from the metal, which is magnesium. So our salt is going to be magnesium, first part of the name. Second part of the name comes from the acid. It's sulfuric acid, so the second name is going to be sulfate. It'll be magnesium sulfate. What else are we going to get? Look at your general equation. We're going to get hydrogen as well. The following video is going to show you your observations, show this reaction happening. So you can be writing your observations in as we go along, but we'll check them afterwards. But we're writing them in as we go along. Okay, we're now looking at the reaction between a metal and acid. We're going to do the reaction of magnesium metal with sulfuric acid. So I'm going to pour my sulfuric acid in one of my boiling tubes, fill it about halfway, or just less. And we've learned from our general equation that in this reaction we produce a salt and hydrogen. And so because of the formation of hydrogen gas, I would expect bubbles to be given off. So what we want to look at are the observations here. So I'm going to put my magnesium into my boiling tube, and then I'm going to place another boiling tube on top. The purpose of that is to collect the gas that's given off, and then I can test that gas to confirm that it is hydrogen. So if you look what's happening here, the colourless solution of my acid, it's staying colourless. There's no colour change in the solution. But you can see that the metal is fizzing. There's lots of bubbles of gas being given off. We can also describe this as effervescence. You won't be able to see this from the video, but if we feel around the outside of the test tube, we can feel that it's giving off a lot of heat. This reaction gives off a lot of heat. And you can see the hydrogen passing into the other boiling tube. So we'll let a bit more of it collect, and then I'm going to test it using a lit splint. So you also need to be familiar with the test for hydrogen gas. The test for hydrogen gas is that I apply a lit splint and a popping sound should result. So if you just let the magnesium react a little bit more, one of your last observations is that the metal eventually disappears when the reaction is finished, leaving a colourless solution. So we can see most of it is reacted. I've collected about as much hydrogen gas as I'm going to get. So I'm going to light my splint in the Bunsen burner. And then very carefully, I'm going to lift off my boiling tube, apply my lighted splint, and I should hear a popping sound. Okay, you can see the flame that was produced there, and that is hydrogen burning, hydrogen exploding. And if you have a look at the test tube now, you can see that it looks like it has a lot of condensation around it. And if we let that cool a bit, you would see that the gas, the condensation around the walls of the test tube would form a liquid. And that's because when you react hydrogen with oxygen, which is what is happening when we do this pop test, the product is water. So the condensation around the walls of the test tube is actually water. So back to page 13 again, I'm thinking of our observations. In that reaction we saw fizzing, or you can describe it as effervescence. But don't write both down, because, well, you can write both down, but you won't get two separate marks for it. Fizzing or effervescence mean the same thing. We saw that heat was released. Well, you weren't really able to see that from the video, but if you felt around the outside of the boiling chip, it would have been very hot. So heat is released. We see that the strip of magnesium disappeared. So remember back to your general observations as well. We talked about if a solid's used, it will disappear. So the magnesium disappears. And what are you left with at the end? You were left with a colourless solution. So colourless solution produced. That's 4 separate observations that you would need to write for the reaction of magnesium with sulfuric acid. There's another example in your table, and that's for calcium and a hydrochloric acid. And you can see that it's exactly the same observations. Bubbles of gas produced, it's the same thing as saying fizzing. The heat is released. Calcium disappears, because obviously we're using calcium instead of magnesium, and a colourless solution remains. We need to just have a think about our products. So remember, our products are salt and hydrogen. What's the name of our salt? First part of the name is going to be calcium. Second part of the name comes from hydrochloric. Think back to part 2 video. What does hydrochloric acid change to? It changes to chloride. So our salt is called calcium chloride, and then we produce hydrogen as well. Okay, and from that last reaction that we looked at for calcium and hydrochloric acid, we've been asked to write the equation, the word equation for that, and then the balance symbol equation. If you want to give this a go yourself, you can pause this video, try it, and then you can check as I work through, or you can work through it with me if you're not completely sure. So, we essentially have the word equation written because we said that when you react calcium with hydrochloric acid, we wrote our products in the right hand box. If you can, try and fit the whole word equation into one line. So the first part of the name of your salt comes from the metal, so that's calcium. Second part of the name of your salt comes from the acid. Hydrochloric acid changes to chloride, so it's calcium chloride. What's the other product? Look to your general equation. It's hydrogen. Okay, so your general equation will help you with that, and then you just have to name your salt from the metal and the acid that we used. Okay, so now it's time to write our balance symbol equation. For calcium, it's just a simple case of writing down its symbol. So calcium is Ca. Hydrochloric acid, you need to be familiar with the formula of it. We wrote it down on page 12. So you can look back to that, but you need to be familiar with this formula that it's HCl. Okay, we've formed calcium chloride. I've left a bit of space so you can do your swap and drop here. So where your term has 2 names, now where your substance has 2 names, you need to do swap and drop. So calcium is Ca. Chloride just comes from chlorine, which is Cl. Think about your valencies now. Calcium is in group 2, so has a valency of 2. Chlorine is in group 7, so has a valency of 1. Can't cancel those down at all, so I swap and drop them. The 2 is now going to belong to the chlorine. The 1 I can leave out because I don't include 1s in my final formula. So I write Ca, Cl, and then I'm going to write the 2 in green to show that that came from the calcium. Plus hydrogen. So hydrogen is, the symbol is H, but we need to remember with hydrogen that it's diatomic, so you need to put a 2 afterwards. If you forget that it's diatomic, then that causes real problems when we come to balance this equation. So I've written my equation, and even if you found balancing hard, I would encourage you to try and get to this stage, because you'll get a mark for the formula on the left, the mark for the formula on the right of the equation, and then a mark for balancing. So what do we do when we balance? Well, the first thing we do is make a list of the elements we have. So we have calcium, we have hydrogen, and we have chlorine. Make sure to write them out all separately. On the right hand side, then copy that list in the same order. Calcium, hydrogen, chlorine. Next step, count them up. And at any stage that you feel you're happy doing this, maybe pause it, try it, and watch back to check you've done it correctly. Because you need to get to a point where you can do this by yourself. So how many calciums do I have on the left? I have one hydrogen, and 1 chlorine. On the right now, let's count them up. I just have 1 calcium, I have 2 hydrogens because of the little 2 after it, and I have 2 chlorines. So you can see my calciums are balanced, but my hydrogens and my chlorines aren't. If you find writing the boxes helpful, I'll do them now, but you don't necessarily have to do them. At this stage when we're balancing, we can only put big numbers in the boxes. Okay, so I need 2 hydrogens and 2 chlorines on the left. How am I going to achieve that? I'm going to achieve it by putting a 2 in front of my HCl. What I need to do now then is update my list. So that 2 multiplies everything in the formula by 2. So I now have 2 hydrogens and I have 2 chlorines. You can check your list now and you can see that that is balanced. If you have written the boxes, it's important that you rewrite your equation without the boxes. So all of this working out you would have done on a spare page, and then just write your final answer on the line. So it's Ca plus 2 HCl, because I had to put a 2 in front of that to balance it, gives you CaCl2 plus H2. That's your final equation. You now need to write an equation for the reaction of magnesium and sulfuric acid, which was the other equation on the last page. Why don't you try and write the word equation and the balance symbol equation. Pause the video while you do this, and then I will go through it step by step. If you're struggling, you can work through it with me, but do try and do it yourself and then see how you get on. So we see that when we react magnesium with sulfuric acid, think back to your general equation. Metal plus acid gives you a salt plus hydrogen. Our salt has 2 names. First name comes from from the metal. That's magnesium. Second part of the name comes from the acid. I've got sulfuric acid, which changes its ending to sulfate. Magnesium sulfate. General equation tells us that we always get hydrogen in these reactions. Again, try and fit it all in one line if you can. Okay, now time to write our balance symbol equation. First step is by converting all of our names into formula. So let's take our first name. It's just magnesium. So magnesium is Mg. We've added that to sulfuric acid. What's the formula of sulfuric acid? Again, we wrote it on page 12, but you need to know this formula. It's H2SO4. Okay. Draw your arrow then, magnesium sulfate. To do that, we need to do our swap and drop method. So, convert to our formula first of all. Magnesium is Mg. Sulfate, I think you would be better to learn that sulfate is SO4 with a valency of 2. But if you have forgotten that, look to the back of your periodic table. It appears as SO4 2 minus. So at this stage what I want to do is just write SO4 down. So everything in the formula apart from the charge. Okay, and then I use the charge for the valency. So let's just look at that now. Our charge gives us the valency. Because it's 2 minus, my valency is 2. Magnesium, I get its valency from its group number. Magnesium's in group 2, so it has a valency of 2. Look at my valencies. Can I cancel them down? Well, yes, I could divide both numbers by 2. That would give me Mg1 and SO4 1. And then when I swap and drop those, I end up leaving my 1s out because I don't include 1s in final formula. So I end up getting MgSO4. Didn't need to use brackets this time because I wouldn't have a number outside my brackets of sulfate. Okay, plus hydrogen is plus H2, again because it's diatomic. Every time you write hydrogen on its own, it must be written as H2. Okay, time to balance now. Make a list of your elements. Well, I've got Mg, I've got hydrogen, I've got sulfur, and I've got oxygen. Make sure to write them all separately. Copy that list on the right hand side. You've got Mg, H, S and O. Count up how many elements you have. So on the left you have 1 magnesium, 2 hydrogens, 1 sulfur, 4 oxygens. And on the right you have 1 magnesium, 2 hydrogens, 1 sulfur and 4 oxygens. So what you can notice from this equation is that it is already balanced, which is a good job. You don't have to do any balancing, so you just leave it at that. Over on the next page you have a couple more examples. I want you to try and give these a go yourself, because it's so important that you know how to do these. Pause them, do them on a spare page if you're not sure, and then write them into the booklet once you know they're correct. But I don't want you just copying them down from the video. You need to be able to do this yourself. So pause the video now, try these examples, and then I'll just give you the final answer. I'm not going to go through them step by step. Okay, so when you're writing these equations, you need to keep your general equation in mind. So metal plus acid gives us a salt plus hydrogen. Okay, so in this case our metal is zinc, our acid is sulfuric acid. The salt that we produce is going to be zinc sulfate, first name from the metal, second name from the acid, and then we get hydrogen. The only thing we need to be careful here with is our formula of zinc sulfate, and how we get that is on the back of the periodic table. Zinc is a transition metal, so it doesn't have a valency from its group number, because it doesn't have a group number. If you look at the back of the periodic table, it appears as Zn2+, and that's when it's an ion, that's when it's part of a formula. Okay, so zinc has a valency of 2. Sulfate then is your SO4 with a valency of 2. That's going to cancel down to give you Zn1, SO4 1. Those valencies cancel down to 1 to 1. And then when we swap and drop, we'll end up just with ZnSO4. So your final equation should be Zn plus H2SO4, giving you ZnSO4 plus H2. Okay, having a quick look at that equation, you can see that it's already balanced, but you can make your list and check if you need to. Moving then on down to sodium and nitric acid. Again, if you haven't had a go at this, please pause the video and try it yourself, and then I'll go through it. So your word equation for this should be sodium plus nitric acid. Okay, keep the general equation in mind. You produce a salt. We've got to name that salt first of all. So the name of the salt is going to be sodium nitrate. So the second part of the name comes from nitric acid, which changes to nitrate, and then plus hydrogen. If you haven't had a go at trying the balance symbol equation, pause the video, try it, and then watch on. Okay, sodium, its formula is Na. Nitric acid, its formula, which you need to know, and it's written on page 12, is HNO3. Sodium nitrate then, I need to do my swap and drop. Sodium is Na. Nitrate appears in the back of your periodic table as NO3 minus. So write down first of all NO3, write down the whole formula including that little 3 at the end, but just not the charge. Then let's get our valencies. Sodium is group 1, so it has a valency of 1. Nitrate has a charge of minus, so its valency is also 1. So when I swap and drop those ones, I can ignore the ones, and I don't need brackets because I'm not swapping down a number. So it's just Na NO3. plus hydrogen, which is H2, remember, because it's diatomic. At this stage you would see that your equation's not balanced, so I need to make my list of my elements. Okay, split them all up. I've got sodium, Na, I've got hydrogen, I've got nitrogen and oxygen. Need to write them all out as separate. And then on the right I have sodium, nitrogen, sorry, I will copy it out in the same order. Sodium, hydrogen, nitrogen and oxygen. Okay, count up how many elements you have on each side. On the left I have 1 sodium, 1 hydrogen, 1 nitrogen, 3 oxygen. On the right I have 1 sodium, 2 hydrogens this time, 1 nitrogen and 3 oxygens. Okay, remember I can only balance the equation by putting big numbers in front of the whole formula. So if you need to put your boxes in front to remind you of that, please do. But let's have a look at how we balance this. Well, we can see the only element that's not balanced is hydrogen. How do I get 2 hydrogens on the left? The only thing I can do is put a 2 in front of that whole formula. I cannot add a 2 in the middle of the formula to get an extra hydrogen. So what that 2 does is it multiplies everything in the formula by 2. So I need to change the list for everything it affects. So I've now got 2 times my 1 hydrogen, which is 2. I've got 2 times by my 1 nitrogen, which is also 2. And then I've got 2 times by my 3 oxygen, which is 6. So I've fixed my hydrogens, but I've actually created a problem with my nitrogens and my oxygens. How am I going to get 2 nitrogens on the right? Well, I need to put a 2 in front of the sodium nitrate. And I'm going to do it in a different colour to show how we've done this stepwise. So put a 2 in front of your sodium nitrate. Change your list as to what that's affected. So I've now got 2 sodiums, I've now got 2 nitrogens, and I've now got 2 times my 3 oxygen, which is 6. So I've fixed my nitrogens and my oxygens, but I've created a problem with my sodiums. So I'll pick one more colour. How do I get 2 sodiums on the left? I need to put a 2 in front of my sodium. So that gives me 2 sodiums. So you need to do that step by step. Don't be tempted to cut corners, put numbers in the middle of the formula. It has to be big numbers in front of the whole formula. So your final equation would be 2Na plus 2HNO3 plus, gives you in an arrow 2NaNO3 plus H2. And that's your final equation. One more example on page 16. So again, pause the video, give it a go, and then check that you've got the final answer. The more practice you get at these, the better. So this time we have lithium as our metal. We have sulfuric acid as our acid. Okay, think to your general equation, you're going to get a salt and hydrogen. The name of your salt will be lithium sulfate. Lithium from your metal, sulfate from your acid, plus hydrogen. Always plus hydrogen at the end. Okay, let's convert that to a symbol equation. Lithium is Li, sulfuric acid is H2SO4. You need to be familiar with that formula by now. Lithium sulfate, I need to do my swap and drop. So lithium is Li. Sulfate appears in the back of your periodic table as SO4 with a charge of 2-. I think you're probably even better just learning that. So sulfate is SO4 with a valency of 2 because of its charge of 2-. Lithium is group 1, so it has a valency of 1. So when I swap and drop these, I'm going to get Li2 that is swapped down from my from my sulfate, and then just SO4. I've swapped down a 1 from my lithium, so I don't need to include that in my final formula. Plus hydrogen, which is H2. Remember, hydrogen is diatomic. Having a quick look at the equation, although you're best to write out your list. The only problem we have is with lithium, there's 2 on the right and only 1 on the left. I fixed that by putting a 2 in front of my Li on the left, and that's it then balanced. But you should make your list and do it step by step. Okay, so the last thing to do with this reaction, this first reaction of acids, the reaction of acids with metals, is to do with the test for hydrogen. And I demonstrated that in the video, gave you your step-by-step method, but let's just have a look at the equation for that reaction. So how we test for hydrogen is often referred to as the squeaky pop test, but if you were asked in an exam how do you test for hydrogen and you just wrote squeaky pop test, you wouldn't get the marks. What you need to do is describe how you actually do that in practice. So how you do that, as I showed you in the video, is to first of all apply a lighted splint or a lit splint to a test tube containing hydrogen, and if there's hydrogen present, then a popping sound will result. That would be a 2-mark question, and there's where you would get your 2 marks. What actually happens when you apply your lighted splint is you're setting the hydrogen on fire. It's exploding. And what it's really doing is it's reacting with the oxygen in the air. So if we think about hydrogen, the formula for hydrogen is H2 because it's diatomic. It's a gas. It's reacting with the oxygen in the air, which again, oxygen is diatomic, so it's O2. Again, it's a gas. And what we get when we react hydrogen with oxygen is water, which you know the formula is H2O, and it is a liquid, so we put an L after it for its state symbol. Okay, looking at that equation, it's not balanced, so what I need to do is I need 2 oxygens on the right hand side. I can't just put a 2 afterwards, that would make it actually hydrogen peroxide, so I need to put a 2 in front. So if I put a 2 in front, I now have my 2 oxygens, but I have 2 times by my 2 hydrogens, which is 4. So I need to put a 2 on the left hand side as well. So that would be the equation for what is happening when we do the hydrogen pop test. But make sure you describe it as apply a lighted splint and a popping sound will result.